So might have wondered always that what is the actual formula for the mean squared error loss function, popularly known as MSE. So some of you might have seen the MSE's mean squared error loss function, which is the accurate algorithm, actually accurate loss function to minimize the error in the case of a linear regression model. For example, if we have this best fit line passing through this data set, then we are trying to minimize these distances. That is predicted value y hat and actual value y. The distance between these has to be minimized on an average through the whole data set. So somewhere you might have seen this formula written as like this: 1 by 2m summation of 1 from I1 to n predicted value y hat minus actual label whole square. Or some of you might have seen it like this: 1 by m minus 1 summation over 1 to m y hat minus y whole square. Or somewhere you might have seen like this: 1 by m summation over all the training data instances 1 to n y hat minus y whole square. So this can be a one formula you might have seen. This can be a one another formula you might have seen, and this is the most popular one that most of you might have seen. Now, you most of while I was studying machine learning initially, I was always confused at which of the formulas to use where. But later, from my experience, I came to know that all of these formulas perform the same job. Let me explain to you in a better way. So, what the means for error actually does, it tries to minimize the sum of residuals. It's its name. In the name, it is present. Mean squared error. So, what is the error here? The residuals, predicted value, and actual value difference. Square these residuals and take a mean over the whole data set. For example, this is your data set. These are the number of features that you are using, and this is the size of the data set, number of training data points. Okay, it's one features and names. Right. So all these formulas actually perform the same thing. Let's see. So first we take this formula 1 by 2m summation y at minus y whole square. So why do we use this 1 by 2m? Why not only 1 by m summation y minus y hat whole square? So you know that the optimization algorithm that is used, for example, if we're trying to find the best fit line for the whole data set, let this line be wx plus b. Uh, sorry, only to move to this white code. Okay. The y hat is equal to wx plus b. Actually, it should be w transfer x plus b, but for simplicity, I'm taking wx plus b. So, for example, if we try to, okay, after that, if you use gradient descent algorithm, I'm sure many of you are familiar with this algorithm, which is an optimization algorithm which iteratively finds the best weights and biases of the model. So in this derivative of loss with respect to W, our loss is what? The mean squared error, right? And with respect to W. Now, the loss which we are going to use here is this, right? So using chain rule of differentiation, you know that y minus y hat whole square is equal to W. This will, I'm talking about only about this term, right? This will give what? Using chain of differentiation, we will put y minus y hat first and y minus y hat here. So it will be 2 y minus y hat and whatever this one is, y minus y hat, but it will be minus x, but it's little for here now. Now, here you can see an extra 2 coming here. Now, if we, and this was the loss, actually, this was the mean square error loss, right? I only use this one. So if we had a 1 by 2 and multiplied with this, since it is a constant value, so it will come out of the partial derivative formula. It will cut it. Now you can see its proficiency increases because the two that we have got, we might add in extra steps and might have required extra calculations in future. This is the eradicator. That's why we use 1 by 2. Another formula that we use 1 by m minus 1 summation y minus y hat sorry, y hat minus y whole square, doesn't matter which way you write. This n minus 1 is used to reduce the bias in the system. It's not too much to learn that how it reduces bias, it's scientifically proven. And another formula that we use, 1 by m y minus y hat square, which truly adheres to the name of the mean square error. So in all these formulas, one thing you might have seen common, 1 by m minus 1, 1 by m. So what is this? Sum of observations, that is sum of residuals, sum of squared residuals, should say sum of squared residuals divided by, I'm sorry for writing, sum of squared residuals divided by number of observations or number of observations in the whole data set. So sum of observations or number of observations. What is this average? So you are just taking the average of these residuals in all these cases. So in a nutshell, you can use this formula, this formula, this formula, doesn't matter. What you're trying to do is you are just trying to reduce the average value of these residuals iteratively. For example, in first iteration, this was the wasted line, this was the y hat, this was the y for this data point, this was the y hat, and this was the y for the second data point. In second iteration, you got this line, this is no, this is the y hat one. So in each iteration, you are iteratively reducing this average value of these residuals to the whole data set. That is, if these are the residuals and this is the average of residual, you are trying to minimize this in every step. So this is what all the formulas are showing here in the mean square error function. So whichever you use doesn't matter. It all gives the same result. Thanks.